The next video lecture is on control technologies in automation. First one, that is industrial control systems. The control systems is one of the three basic components of an automation system. We examine industrial control systems, in particular how digital computers are used to implement the control information in production. Industrial control is defined here: automatic regulation of unit operations and their associated equipment, as well integration and coordination of the unit operations into the larger production systems. In the context of this context, the term unit operations usually refer to the manufacturing operations. However, the term also applies to the operation of manufacturing, handling, and other industrial equipments. Now, the process industries versus discrete manufacturing industries. Process industries perform their production operations on amount of the material, because the materials tend to be liquids, gases, powders, and similar materials, whereas discrete manufacturing industries perform their operations on quantities of materials, because the materials tend to be discrete parts and products. The kinds of unit operations performed on the materials are different in the two industry categories. Some of the typical units operations in each unit category is shown in the figure. Now, the levels of automation in the two industries. The significant differences are seen in the low and intermediate levels. At the device level, there are differences in the types of actuators and sensors used in the two industries categories, simply because the processes and equipments are different. In the process industries, the devices are used mostly for the control loops in chemical, thermal, and similar processing operations, whereas in discrete manufacturing, the device controls the mechanical actions of machines. At the next level above, the difference is that unit operations are controlled in the process industries and machines are controlled in the discrete manufacturing operations. At the third level, the difference is between control of interconnected unit processing operations and interconnected machines. At the upper level, that is plant and enterprise level, the control issues are similar, allowing for the fact that the products and processes are different. Now, the variables and parameters in the two industries. The distinction between the process industries and discrete manufacturing industries extends to the variables and parameters that characterize the respective production operations. In the process industries, the variables and parameters are of interest tend to be continuous, where in the discrete manufacturing they tend to be discrete. A continuous variable is one that is interrupted at time periods and also as the time proceeds, at least during the manufacturing operations. A continuous variable is generally considered to be analog, which means it can take on any value within a certain range. The variable is not restricted to a discrete set of values. Production operations in both the process industries and discrete parts manufacturing are characterized by continuous variables. Examples include force, temperature, flow rate, pressure, and velocity. Of all these variables, whichever one is applying to a given production process are continuous over time during the process, and they can take on any of an infinite number of possible values within a certain practical range. A discrete variable is the one that can take on only certain values within the given range. The most common type of discrete variable is binary, means it can take on either two possible values, on or off, open or closed, and so on. For example, discrete binary variables and parameters in manufacturing includes limit switches, open or closed, motors, on or off, and the part presents or not present in a fixture. Not all the discrete variables are binary. Other possibilities are variables that can one more than two possible values, but less than an infinite number, that is discrete variables other than binary. Examples include daily piece counts in a production operations and display of a digital tachometer. A special form of discrete variable is pulse data, which consists of a train of pulses as shown in the figure. As a discrete variable, a pulse train might be used to indicate piece counts. For example, parts passing on a conveyor activate a protocol to produce a pulse for each part detected as a process parameter. Okay. As a process parameter, a pulse train might be used to drive a stepper motor. Now, the next one, that is continuous versus discrete controls. Now, industrial control systems are used in the process industries have tend to emphasize the controls of continuous variables and parameters. By contrast, the manufacturing industries produce discrete parts and products, and controllers used here have tended to emphasize discrete variables and parameters, just as we have two basic types of variables and parameters that characterize production operations. We also have two basic types of controls. First one is continuous control, in which the variables and parameters are continuous and analog. And second one is discrete control, in which variables and parameters are discrete and mostly binary discrete. Some of the differences between continuous and discrete controls are summarized in this table. In reality, the most operations in the process and discrete manufacturing industries tend to include both continuous as well as discrete variables and parameters. Consequently, many industrial controllers are designed with the capability to receive, operate on, and transmit both type of signals and data. Now, the continuous process and its forms. There are two ways in which the computers can be used to control a process. First one, we can distinguish between process monitoring and process control as illustrated in the figure. In the process monitoring, the computer is used to simply collect data from the process, while in the process control, the computer regulates the process. In some process controls implementations, certain actions are implemented by the control computer that requires no feedback data to be collected from the process. This is open loop control. However, in most cases, some forms of feedback or interlocking is required to ensure that the control instructions have been properly carried out. This more common situation is closed loop controls. That means in the closed loop control systems, there will be the feedback system, whereas it is absent in the open loop control systems. Thank you.